All right, this is section 1.5, triangles. So we're going to go, you'll be able to identify and sketch particular types of triangles, okay? You'll definitely be able to classify them. So the first one we want to classify is the right triangle. So you have two pictures of right triangles below. They can be shown different ways. One thing that I do want to stress, though, is if you see a picture like this, that is not a right triangle, okay? Even though it looks like this angle right here could be right, it doesn't have proof. So I've been talking about this year, how everything has to have proof and it has to be marked. Can't go by looks. So this would not be a right triangle, not until you see either a box like over here or an actual 90-degree sign, okay? So there's only one right angle in each one, and so a good definition would be a triangle with one right angle. Okay, so that's a right triangle, and I'm sure you've heard of this before. Next one is the acute triangle. We have two examples of two acute triangles. You'll notice all three angles shown in each picture is acute. So an easy definition would be a triangle with all acute angles. Okay, not one can be obtuse. So be able to identify or sketch acute triangles. Next one is obtuse triangle. You'll notice in each picture, those are examples of obtuse triangles. Each one you have at least one obtuse angle. So we've got an obtuse angle here, an obtuse angle here. Okay, so it's going to contain one obtuse angle. So it's a triangle with one obtuse angle. Okay, cannot have two obtuse angles because then it wouldn't be a triangle. So one is obtuse, the other two have to be acute. Next one is a scalene triangle. Okay, a scalene triangle is identified by its sides. So you classify this particular triangle according to its sides. So the last three that we just did all were related to their angles. So those are classifications by angles. On this one here, we're going to start classifying by its sides. So you'll notice the sides are all different. Okay, so this would be a triangle with no congruent sides. Okay, triangle with no congruent sides. And so in particular, this one over here to the right, you can see it's a right triangle. So you can identify it or classify it by two different names. So this one would be a scalene right triangle. Over here on the left, this one's a pretty obvious obtuse angle. So this one can be identified as a scalene obtuse triangle. So now you can identify it and classify it by two names to be specific. Next type of triangle is equilateral triangle. And you'll notice equilateral, you learned before, means all sides congruent. So this is pretty obvious. Now there's a unique thing about the triangle when it's equilateral. When it's equilateral, it is forcing all the angles to be congruent. Okay, so it doesn't show it over here on the triangle to the right, but you now have to know that it forces them to all be congruent, okay? And this is the only shape that works for. So for a quadrilateral, if it's equilateral, it doesn't necessarily mean that it's going to be equal angular. It can be, but doesn't have to be. Over here, it has to be. So if it's equilateral, then it's equal angular. So definition we could say is a triangle with congruent sides and congruent angles. Okay, now you don't ever have to say both because of what I kind of just talked about. If all three sides are equal in a triangle, then it's automatic that the angles are equal. Okay, and it works the other way too. So if you see a triangle like this and it's showing that all three angles are equal, you now have to know that, well, all three sides must be equal. Okay, and that's just the way geometry works. Okay. Next type of triangle is an isosceles triangle. I think you've heard of this before, but one thing that that you probably didn't know is put a little star on this first picture and definitely draw it. Notice it has all three. This one's the equilateral. This one is also known as an isosceles triangle. So a definition, and then you'll notice over here these two sides are equal, and then over here these two sides are equal, but not necessarily the third. So definition is it's a triangle with at least two sides congruent. A triangle with at least two sides congruent. So you're probably saying, well, how come the equilateral triangle is also known as an isosceles triangle? Because the equilateral triangle holds the same properties as the isosceles triangle. So it can also be considered that. Now, we want you to refer to this, though, as an equilateral triangle, because that's the more specific name that we would like for you to use. Okay, but yes, it does have all the properties of the isosceles triangle. That's why it's also under this category. Some important parts that we want you to know about the isosceles triangle. You'll hear your teacher say these particular terms, and so you got to know what which part they're talking about. So the obvious ones, these two sides here, okay, they're going to be referred to as the legs. Okay, sometimes some teachers say the legs or just the congruent sides. So this one and this one are known as the legs or the congruent sides. This side down here at the bottom is known as the base. Now I said bottom, that doesn't mean it's always at the bottom, because if I draw an isosceles triangle like this, well, now your base is up here at the top. That would be your base because these two are the legs, the congruent sides. Okay, so it's the base because it's the non-congruent sides. Okay, since that's the base down there, the two angles right there next to the base, we'll refer to those as the base angles. And then the angle between the two congruent sides is known as the vertex angle. So anytime we talk about vertex angle, base angles, the base or the legs, just you have to know what we're referring to when it comes to this isosceles triangle, okay? Okay, so let's classify some of these triangles. So over here on the left, we have a triangle. Looks like all the angles are acute. They're all 60, and then all sides are congruent, okay? So I know some of you are probably going to say acute equilateral triangle. You don't necessarily have to do that because all equilateral triangles are always acute. So if you just say equilateral triangle, that would be a good enough term to classify this one, okay? So you don't need to have acute. If you do have it, it's okay too. It's not going to be incorrect. Over here to the right, we see a triangle with nothing labeled. So when there's nothing labeled, you cannot assume sides to be congruent, even if they look like they are. So this one doesn't look like either one is. Looks pretty scalene, if you ask me. So we're going to say scalene triangle. But I will say this, if you see a triangle that looks like this, that looks like some sides could be congruent, but notice nothing's marked. So this one is still considered scalene because they didn't mark anything for you. Okay, so you have to have tick marks or you have to have measures like the one on the left. Over here, C, you have a triangle. It looks like you've got one obtuse angle and you've got two sides showing to be congruent. So to give the most specific name, it's isosceles because these two sides are congruent, and you have this obtuse angle here. So we're going to say isosceles obtuse triangle. Okay, so we want to give both of those names. Over here to the right, we have a right triangle, and looks like all three sides are different. So we're going to say scalene right triangle. Okay, and if you flip-flop those, if you say right scalene triangle, it's the same thing. Or obtuse isosceles. Okay, last problem. It says find point C so that triangle ABC is isosceles. List all possible answers. So where can C be in order for this to be isosceles? So right off the bat, I know many of y'all are thinking, well, I could put a point right here, and then I can connect it like this, and these two sides are going to be congruent, and that is correct. Okay, I can also put a point even a little higher, and I can go like this, and those two sides would still be congruent. Okay, I could even go down here and connect like this. Okay, and so you're probably saying, well, yeah, you could do that all day long. You can pick infinitely many answers, and that is correct. So here's how you want to write that out. You want to write it out by saying 0 always coming first, because it's always going to be 0 something. So like this one here was 0, 2. This one here was 0, 5. This one here was 0, -4. So it's 0 and some number. And so when we want to represent any number, we're going to say y in this case because it's on this side of the coordinate, which is always y. Okay. Now there's one number that it can't be, and it can't be -1 because then it's going to be on that side, which is not going to create a triangle. So one thing that we need to say is that y cannot be -1. Okay, and this is how you list or write it down for infinitely many answers. Okay, now there's actually some more answers. Okay, because what if, let me get a different color. What if this side, okay, we know a side AB is 6 units big, okay? So it's 6 units long. Well, what if I count directly up 6 units, okay? 1, 2, 3, 4, 5, 6. Put a point right here, draw this side. I can connect it with this one, and now this side is congruent to that side, okay? So this is a possible answer right there for C also. Okay, so I'm going to write that one down too, which that's a clear coordinate of being 3, 5. So 3, 5 is also another answer for C. Okay, because we have to list all the possible answers. Okay, let's try another one. Get a different color. If I do that same kind of concept but go down 6, 1, 2, 3, 4, 5, 6, it would be right here. And I would have this one here. Okay, so that could be 3, -7. Okay, and then obviously we can go to the opposite side as well. I can come over here and make another isosceles triangle right here. And so that would be -3, -1. Okay, and then I can make one more down here. And that can be -3, -7. Okay, and I think that's pretty much every isosceles triangle I can make. Okay, you've got all of these answers right here that could all represent C. Okay, and there's infinitely many answers over here, and then you've got these 4 specific answers down here. And that's it for triangles.